Okay, this lesson is on the derivatives of inverses. And what I want you to remember, first of all, is what you know about inverses from previous math classes. The first and most important thing is that x's and y's are switched. And so that's what helps us find inverses and work with them and things like that. The graph is flipped over the line y equals x. And a really good example of that is thinking about your exponential graph and your logarithmic graph. They are flipped over the line y equals x, and it's a really good visual that you guys know from your toolbox functions. But those are inverses of each other. The next is the horizontal line test. If the function passes the horizontal line test, then its inverse will also be a function. But then this last rule is one that you learned in pre-calculus that we are going to use to get our derivative rule today. And if you did not learn it in pre-calculus, here's what we're saying. If you do a composition, like f of g of x type thing, with f and its inverse, so a function and its inverse, if you do a composition, if you substitute one into the other, you get out an x. And it doesn't matter which way you do it, if you do f of f inverse or f inverse of f. Either way, when you do that substitution, you get out an x from that. And in pre-calc, I had you work, several of those and show that they were inverses using that rule. So now we're going to find the derivative rule. Okay, so we're going to bring calculus into this. We're going to use this up here that we were talking about, the composition topic there. What we know is that if we do a composition, f of f inverse, we get x out. Think about taking the derivative of that. I've had you guys take derivatives of f of g of x type things and use a table in here. So this is a chain rule. You do the derivative of the outside, you keep the inside the same, and then you multiply by the derivative of the inside. Okay, so this step right here, and then we took the derivative of x is 1. So we took the whole equation's derivative. But this part right here is just looking at the chain rule, which again, you guys have done with tables in this class. Then, what we're doing today is solving for this piece. So to solve for that piece, I just divide by this piece. So I divide by that on both sides. It goes under the 1 over there. And the derivative of my inverse is 1 over the derivative of f inverse, written as a composition type thing. Now, what you need to do is, even if you don't understand this, you need to memorize this. You need to memorize this. I'm showing you the other part to show you how to get it if you do forget what this rule is. So some of you are probably just going to memorize the rule. Others of you are going to remember where it comes from and be able to produce it when needed. So it's your choice. I just need to know for you to know that equation. Okay, so let's do a few examples. With these examples to begin with, we're going to be given some information. I'm given that f of 3 is 7 and f prime of 3 is 2. I'm trying to find f inverse prime of 7. So this is where that rule comes in, and I'm going to use 7 in place of those x's. So f inverse prime of 7 is 1 over f prime of f inverse of 7. Okay, so I'm just using that rule to write out my problem. And the things that I'm going to find, I'm going to work from the inside out. So the very first thing I'm going to find is, what is f inverse of 7? Well, they didn't give me f inverse of 7. And that's where my knowledge of inverses comes in the fact that x and y are switched. So I go back to this first thing. If f of 3 is 7, then f inverse of 7 is 3. So a point on the original 3, 7 is the 0.73 on the inverse. The x's and y's are switched. So they just gave me this, but I also know about the inverse. And since f inverse of 7 is 3, I can replace the inside here with 3. So I have 1 over f prime of 3. Well, what is f prime of 3? They actually gave that one to us. F prime of 3 is 2. So 1 over 2. So the answer to f inverse prime of 7 is 1/2. You just have to know how to plug in and how to get those values. Okay, so number 2, I have f of negative 1 is 5 and f prime of 1 is 14. Find f inverse prime of 5. So f inverse prime of 5, knowing my rule, is 1 over f prime of f inverse of 5. So I just write that out. And then I'm going to work from the inside out. Since I'm trying to find f inverse of 5, I come over here. They didn't give me f inverse of 5. They gave me f of negative 1 is 5. That tells me that f inverse of 5 is 1 because the point is switched on the inverse from the original. So the x's and y's are switched. So f inverse of 5 is 1. I can replace f inverse of 5 in my equation. Or excuse me, it's negative 1. Then f, and I'm sure I made a typo right there, f prime of negative 1 is 14. So I plug that in. And I get 1/14 as my answer. Okay, 1 and 2 were like the most basic examples. In number 3, I give you more information. And when this happens, it's almost kind of like when they give you a table and you don't use everything in it. Here, you may not use everything. Before I start, though, I know I'm often looking for an inverse, so I'm going to go ahead and rewrite these points. F of 2 is 6 means f inverse of 6 is 2. And then f of 5 is 1 means f inverse of 1 is 5. That gives me more information that I may need. So I come over and I'm looking for f inverse prime of 1. So f inverse prime of 1 will be 1 over f prime of f inverse of 1. And so, again, working from the inside out, the first thing I'm looking for is f inverse of 1. So f inverse of 1 is 5, because I figured that out to begin with. It was the switch of this point here. So I have f prime of 5 on the bottom. And then I look up and try to find f prime of 5. So f prime of 5 is 15. So my answer is 1/15. So I didn't use everything that they gave me, and they gave me all that stuff to see if I made a mistake, what I would get. So it's almost in there to throw you off and to trick you. This same information can be given to you in a table, and you would use the table just like you've done in the past to come up with these answers. So be prepared for that as well. Okay, now with example 4, we have f of x equals this function. We haven't been given a function yet, and they want to know what is f inverse prime of 1. So I'm going to think about what that means as far as my equation. So f inverse prime of 1 is 1 over f prime of f inverse of 1. Well, f inverse of 1 is something I'm going to have to find. And what that means is, if I'm given this function and I don't know what its inverse is, I think about the x's and y's switching. Normally when something is in parentheses, it's an x. But if we're talking about inverse, it's a y on the original. So what they've really given us that we're going to figure out is when this f of x is equal to 1. We're going to need to solve and find what that x value is when the y value is 1. So I can solve this one by subtracting the 1 and getting 0 equals x cubed plus x. And then if I factor out an x, I get x times x squared plus 1. So I can set those equal to 0. So either x equals 0, or I get x is the square root of negative 1, which is an I, and we don't deal with i's in this class. So obviously f inverse of 1 is 0, because when y was 1, x was 0. So I'm going to take that, I'm going to plug that in. Now I have 1 over f prime of 0. And this is a little easier to find because we're familiar with finding the derivative at a point. So I'm going to take the derivative of the function, which would be 3x squared plus 1, and I'm going to plug in 0. So f prime of 0, 3 times 0 squared plus 1 is 1. That means this denominator is 1, so my answer is 1. Okay, for example 5, we're going to do another problem like that. We're going to have a fraction this time as our function. So again, I start by saying f inverse prime of 0 is 1 over f prime of f inverse of 0. And I have to think, the first thing I need to find is whatever f inverse of 0 is. And again, f inverse of something is a y value on the original. So I'm setting the original equal to 0. Now don't get stressed out by this. Remember that when you have an equation with fractions in them, what you need to do is multiply by a common denominator. In this case, you just have 2x minus 1. So if I multiply both sides by 2x minus 1, it cancels on this side, and I have x plus 2. And then on this side, 0 times anything is 0. So I have a really simple equation. And I subtract 2, and I get x is negative 2. So that means f inverse of 0 is negative 2. And I can plug that in over here. When I do, I now have f prime of negative 2 that I need to find. So I'm going to draw a little line. I'm going to find the derivative. Now, obviously the derivative in this case is going to be a quotient rule, so this one has more work in the derivative. So I take the derivative, bottom, times the derivative of the top, which would just be 1, minus the top, times the derivative of the bottom, which would be 2, all over the bottom squared. So I'm going to simplify that a little bit since I'm getting ready to plug something in. Multiplying anything by 1 doesn't change that. And then here I'm going to multiply by 2, and it's a negative. So please pay attention to that sign. The negative gets distributed as well. So I have negative 2x minus 4. You don't have to simplify, it just sometimes makes your life easier, because like in this case you have the 2x and the negative 2x that go away, and you end up with negative 5 over 2x minus 1 squared. And then plugging in the negative 2 isn't that bad. So f prime of negative 2 will be negative 5 over 2 times negative 2 minus 1 squared. So that would be a negative 4 minus 1 is a negative 5. Squared will be a positive 25, and this becomes negative 1/5. Now, since that's negative 1/5, I plug it in up here, where it replaces the f prime of negative 2, and I have to flip and multiply. So I get negative 5 as my answer on this one. And again, example 4 and example 5 are, about as hard as it gets. It's just sometimes you have a little bit harder of an equation to solve, and sometimes you have a little bit harder of a derivative to solve. So that's why knowing your derivative rules and knowing your algebra skills are very important in this type of problem.